Hi, my name is Paul Flynn. We're here today to do basic maintenance on a Biomicrobics FAST system. I'm the Director of Field Operations with Biomicrobics in Kansas City, Kansas. All right, we're going to do the basic system overview, show you the basic system components here. First, of course, you're coming out of gravity feed out of the house and you have your clean out right up next to the house. Gravity feeds down to the two-compartment septic tank. Settling tank, 24-inch riser over the settling tank portion. 30-inch riser over the baffle wall that splits the settling side from the fast side, and then in your second compartment sits a fast 0.75. That's a 750 gallon a day system. Here's the blower for the fast system right here, right next to it, although you can mount it up to 100 feet away. And then the system goes to an after filter and then surface discharge out to the ditch. These are some of the basic tools you're going to need in doing the basic maintenance on a fast system. First, we have a amp meter / voltmeter. Next, we'll have a dissolved oxygen meter that can also take water temperature. Then obviously you have your standard cordless drill, or a corded drill if you want to, with the bits that you're going to need. A pair of gloves to keep yourself sanitary. You may need a replacement air intake filter, may not. We'll see when we take the system apart. And then you're looking at a sample bottle sampler just for diagnostic purposes of the FAST system. We'll get into that a little bit later. And last but not least, we have the sludge judge down in front here. One of the first things you should do when you come out to a FAST system site is make simple observations. You listen for the blower to be running, smell for any obvious septic odors that may be there, listen to hear if the alarm's going off. This will give you a clue as to what you may need to look at first if the system does have problems. First thing we're going to look at is the blower, make sure it's running correctly, and check the inlet air filter element. So after we removed all the screws from the top of the blower housing that hold the two halves of the blower housing together, we expose the blower unit itself. Take a look at the air filter inlet element, simple wing nut. You get that guy off. A little bit of dirt on there. We can take that and either wash it out with a water hose or an air hose, or just maybe tap it out. We'll get the water hose on this one. Cleaning out the inlet air filter element. It's just a mesh steel filter, so it'll do just fine with water. Just let the excess water drain out. You'll be able to put it right back on the blower intake. Okay, we're taking the cleaned blower air intake filter, putting it back on the blower intake, then putting the canister back together. Washer, wing nut. There we go. At the control panel, this particular control panel, you have 3 lights on it: alarm light, blower functioning light, power light for the panel. In order to turn your blower off, you're just going to hold down that button right there. Your alarm sounds. Silence the alarm with the reset button right there. You have your red flashing alarm light. Turn the blower back on. Simply hold down the blower button for about 3 seconds. Your power light will start to flash, and then your blower will kick on and your blower light comes on. Okay, now we're going to check the electrical on the blower, check the amp draw on the blower. First thing we need to do in order to do that is shut off the power at the control panel. Next, we're going to unscrew the junction box cover on the blower itself. Phillips head screwdriver. And we'll separate out one of the hot legs, or the hot leg, on this blower so that we can get our amp clamp around it. On this blower, that happens to be the wire that is connected to the P1, P as in Paul 1 leg. And in order to determine if you're unfamiliar with whether you have high voltage or low voltage being 110, high voltage being 220, you can look at the schematic on the back cover of the blower's electrical panel or electrical junction box to determine which wire you need to look at. So next we'll get our amp clamp around our hot leg here. and then we'll have somebody turn the power back on. We'll be able to get an amp reading. Let it start up for a few seconds to get the full load. And we got our amp reading. Next thing we'll do then is shut the power back off after we're done taking our amp meter reading, so we can put our wires back in the junction box. Secure the junction box back in place with our Phillips screw. While you have the cover off the blower housing, it's a good idea to check your other connections, electrical connections, air connections associated with the blower. First, we're going to look at the Fernco coupling coming off the outlet of the blower. The Fernco coupling is a great device to use just because it makes switching out the blower very easy when that time comes. But just put your hand around the different connections, see if you feel any air coming out. Also, of course, your PVC connections, see if you feel anything there. Nothing on this one. We also have a pressure switch for detecting high water level in the system. That's on the outlet pipe of the blower. Just real quick, put your fingers, your hand around that switch just to make sure it's in there. Probably give it a little wiggle, make sure it's in there nice and tight. It's a low voltage switch, so you can do that while the power is on if you prefer. If you have a disconnect at the blower, you're going to want to check and make sure that that's doing okay too. Obviously make sure it operates correctly. Close that back up, take a look at your electrical connection, make sure the disconnect's mounted in there correctly and well. And then last but not least, check your blower housing to make sure there's not any debris brought in by mice or other creatures, let's say, spiders, that sort of thing. If there is any debris in there, make sure you clear it out so it's not going to cause any problems in the future. Okay, after we're done checking all the physical parts of the blower and connections, we're going to put our blower housing cover back on. But first, we're going to want to check the louvers on each end of the housing, make sure they're clear, make sure they're not obstructing airflow. These look good and clear. So we're going to put our blower housing cover back on. It's a keyed blower housing, so it only fits one way. And then you're going to put your screws back in place, secure the blower housing back in place. Next thing we're going to do is take a sludge judge of the settling side of the settling tank. Get all the screws off the manhole cover, remove the manhole cover, set her aside, and then we grab our sludge judge. Down through the scum layer, down to the bottom of the tank, hold it there for a few seconds, bring it back up. There's our sludge, about 1.5 feet deep in this tank. Now you're going to drain out whatever you built up in the sludge judge down inside the tank. There we go. And we're ready to put the cap back on. So our sludge judge showed roughly a 38-inch water depth total in the tank. About 1/3 of that is sludge on the bottom of the tank. By our standards, that's a good measurement level to dictate that the tank needs to be pumped. And then when you pump the settling side, you just pump out whatever's built up underneath the fast side also for sludge. Now we're in the second compartment of the settling tank, or of the concrete tank, and we have a 2-compartment tank here. So we have a baffle wall separating the first compartment from the fast compartment, which is the second compartment of this tank. And we're going to take a sludge judge sample of the fast compartment just to make sure we got a good idea of what the sludge level is inside underneath the fast system. So we have roughly 1 foot of sludge underneath the fast system. It's about time it should be pumped. Now we're going to get rid of our sludge judge sample inside the tank. We're going to throw the manhole back cover on this compartment. Drill it back into place. Next, we're going to look at the vent and the turbulence inside the fast system. So the 6-inch inspection riser that comes up off the fast lid inside the fast compartment. It's right here. It has a lot of holes drilled in it for a vent in this circumstance. We're going to take that cover off and then take a look down the 6-inch inspection port into the fast system. I should see the recirculation trough of the FAST unit coming off the airlift. I do. And I should see a lot of turbulence from the airlift splashing the water over the media. And that looks good in this circumstance. Next, we're going to check the water level over top the media. So we take our dry stick, put it down the 6-inch port until we hit the media, bring it back up. We should have about 2.5 inches of water over top the media. Next, we're going to try taking a dissolved oxygen reading out of the FAST reaction chamber. If you have a dissolved oxygen meter or a method for taking a dissolved oxygen sample, it's a good idea to do it. It gives you a good measurement of how healthy the FAST system is. So we're going to take our probe, our dissolved oxygen meter, put it down the FAST reaction chamber till it's in the water by a couple inches. And then since the FAST reaction chamber, the system is operating right now, it's moving water past the probe, which is the proper technique. We're going to wait about a minute, roughly, and then get our reading. Making sure our probe's in there correctly. About 5.25, 5.5 milligrams per liter dissolved oxygen inside the FAST reaction chamber. So we're on the low end of the dissolved oxygen reading for what we want to see ideally in a FAST system. There could be several reasons for that. It could have to do with the water temperature. It's fairly warm, 78 degrees inside that tank. Could have to do with the loading that's on the system. Could have to do with the amount of sludge we have in there that's creating that loading. There's several reasons there, but just to be aware that we are on the low end for this particular unit. So we want to pay attention to other factors that may contribute to that. But then we'll pump the system, and after we have the system pumped from both the settling side and the FAST side, we'll recheck the dissolved oxygen readings, see where we're at from there. Now that we're all done looking at the 6-inch inspection port, we're going to put our vent cap back on, secure it firmly. If you have screws, make sure your screws are back in place too. Last but not least, we're going to want to take a sample of the effluent coming out of the system. We have our sample bottle in our collector. In this case, we've got an open discharge pipe, so it's very easy to collect our sample. You may have a pump tank or a D-box that you're taking that sample out of for a subsurface discharge, but you've collected a decent amount of sample there. You can take a look at it now. Make sure it's relatively clear, like a glass of water. Make sure you don't have any floating particles, large solid particles in there. And then also you want to smell the sample too, just to make sure it smells like just a musty, damp odor, not that septic odor. Last thing you're going to want to do on the site is button up all your manholes, screw them down securely. Pick up your tools, whatever you've left on the site, straighten up the site, fill out your proper paperwork for the site for reporting to the state, whoever, and then tell your homeowner, let your homeowner know what you've found and that you've done maintenance on the system.